Good evening, sir. Let's go to online, sir.
Hey, Papa, hold on.
What did you say, sir?
I'm saying, hey, Papa, walk on.
Oh, not much, not much. I'm here. I'm here.
Nice. Good to see you
Everyone is
out.
here thus far.
Yeah, good to see you out early.
Indeed.
Um, so because you are here early, I'm going to reward you with a question.
Please. I
Yeah,
welcome.
yeah, man. We're on stationary points, right?
Yes.
And I had just introduced it, so I gave it a easy question, right?
Yes, you did. Like
Okay,
to think.
great. All right, good. So I just want to make sure which of the questions I gave you. Um, all right, so I'm going to be projecting this question on. And I would be very grateful if you would just do as best as you possibly can on it. Early bird catch a mouse worm. Are you seeing the screen?
Yes, I'm able to see it now, sir. You were breaking up just now, but I'm able to see it now.
Great, thanks. All right, just give a quick start, and wherever you have, if you're having a difficulty, you can just unmute and ask me. I'm right here just trying to see if I can upload a few of these videos. So message me if you have a difficulty.
Good
No
evening, Mr.
problem.
Shan.
Hey, Papa. Hey, Jesus, please.
Yes, sir. I'm on bail.
No, it's not. It's not that. They get Irish. They get Irish Spring now. Cause this one I think got good foreign. Well, welcome back here, and I apologize for the tardiness, but ay. Yeah. All right.
Appreciate it, sir.
No problem. I'm hoping that you were seeing the notes in the WhatsApp group though and trying to follow and keep
Yes,
up.
sir. Yes, sir. TKL them keep me up to speed. But certain things me not really fully get yet though. But I'm still I practice.
Good job. All right. I sent the Connor something to post just earlier today. Earlier meaning just before the class started. The final draft of the final copy of the timetable.
Yes, sir.
So take keynote. Those of you who need to put in leave request, put them in soonest. And there is a question, Alwyn, that we started one of these big boys last week. A question like this carries about 30 marks. And if we can understand this topic to its maximum and to its fullest, we should be able to pick up the full 30 marks. So I'm going to spend a good portion of today. I'm just giving you questions. It's not really going to be a talky class. Give you questions, we'll look at the solution and give you another question. So I want to see how best you can do it. So go ahead, start. If you're having any difficulty, please unmute and ask me. I will go through the question. I'll explain or answer your questions. All right?
Okay, sir. So that sounds like a plan.
Yeah, man, cool.
Evening, everybody.
Sir, can you share your screen, please? Me transfer over to my laptop, but not see screen again. Okay. See you now.
All right, so I'm seeing good afternoon to those of you who joined after I greeted the class. But I'm seeing people coming in and leaving. I'm not sure if it is unstable internet access, but just if you're coming in or you came in after I've spoken, there is a do know question. I'm going to ask you to start for me, please. If it is that you're having a difficulty, might I suggest that you use the time to go through the last set of notes posted to your WhatsApp group. I'll come to you at 5:25 to go through the question. If you're finished, you can drop your answers as usual. All right, I just see one answer. At the same time, I'm unmuting to start the working out. How far do others of you? Hmm?
So
Still
go
looking
to-
through it, trying to figure out one part.
All right, my people, my people, my people. I'm seeing. All right, sorry. So Demoy, are you seeing the screen now?
Yes, sir.
Okay. All right, so we need to go. Tell me. I know at least one student reach beyond the point of inflection because I'm seeing the messages coming into me. But when you differentiated the function, what did you get? Anybody, somebody? By the way, before you answer, I'll come into you, Damon. 1 minute. What's the first thing to do when you see a question like this?
So differentiate.
Very good. Very good. Okay, Damon, I think you're going to differentiate for me now. Go ahead, please, Hops.
They just want the plus or differentiator.
Yeah, what's the differential of the function y? dy by dx equals what?
3x squared, take away 6x, take away 24 equals 0.
Very good. So that's correct. You'd have gotten a mark here. So that's equal to 0. So you're now going to solve 3x squared minus 6x minus 24. All right. Work with me.
So I'm gonna get 2 value of x.
Yeah, man, you're supposed to. Tell me why you're supposed to get 2 values for x.
Because you have a x squared and you have
Very good. Geez. Andrew, I was going to say something a while ago. No, man, you're right, Andrew. You're right. You're right. You're very right, Papa.
so I'm gonna finish because internet go down, power just go. I'm not even log on to my laptop yet. Internet. No.
No problem. No problem, man. That's not it. Boy. I nearly got myself into trouble a while ago, Andrew. And you see, I'm sending you a message, Andrew, and I'm so happy that it went to somebody else who is not in the class because I was about to send your message to the person. Andrew, check your private message, Andrew. And tell me if you know where that came from. No.
Sir, I said do that, sir.
Oh, goodness, anyhow.
That's gonna be initial, sir.
Well, you would see it, you know, but guess what? I was about to say because I normally do it to students, but I was about to say it and then now I pull back because somebody would have said, yes, man, it's what sir said to Andrew. But anyhow, don't worry about it, Papa. All right, let's go. Very good, Amoy. I'm really very proud of you. And the rest of you who recognize that we have to differentiate the function, excellent. So look at the bottom of the screen. I don't want to project everything at once. So I'm showing the bits by bits. You have the function and you're differentiating the function. When you differentiate the function, you can get 3x squared minus 6x minus 24. And I like what he said. Equals 0, sir. Yes. For stationary point, dy by dx is equal to 0. For stationary points, dy by dx is equal to 0. So you have to remember that. For stationary points, dy by dx must be equal to 0. And then when you solve that quadratic, what did you get?
Sir, 3 bracket x squared minus 2x minus 8 bracket equals 0.
Everybody agree?
Sir, whenever you what you said, 3 minus what?
So you're factorizing the quadratic, seeing what is common. So I have 3 bracket x squared minus 2x minus 8 bracket equals 0.
Yeah, I agree.
Everybody agrees?
All the
Yes,
same
sir.
thing, yes, sir.
Sir, I'm gonna do something slightly different.
Yes, sir. I did something slightly different as well.
Well, if your slight differences
But
are on a slide, you should end up with x minus 4 times x plus 2. Anybody, somebody?
Yes, sir.
Good
yes,
job,
sir,
Ashanti.
that me get, sir. That's how I work out.
Good job,
Yes,
Papa.
sir.
So
Sir,
you
but
don't have
like
to.
how
Go
3
ahead.
x squared, 6x and 4. Yeah, listen, sir. 3x squared, 6x and 24. Then I can divide by 3, sir.
Very good. That's why I said dividing 2 by 3. See here? Dividing 2 by 3 to give me x squared minus 2x minus 8. You see it, Andrew?
Yeah, that me do. Yeah.
Mhm. Question. I need to know this so that I can move on. Is there anyone in the class having a difficulty from this point? Meaning from the point where we set the differential equals 0. Remember, speak now or forever hold your peace. Let me just
No,
pause.
sir.
Come in the final. All right. Let me give you a gentle reminder. I don't want anybody to think that I am holding back the class. I don't want that to happen. The gentle reminder, though, is I am expecting a 30-mark question on this topic. That's what I'm expecting. I cannot tell you definitively that it's coming because I don't know what is coming. But I am expecting a 30-marker for this question. If I'm disappointed that it's not a 30-marker, it cannot be less than 20 marks. Can't be less than 20 marks. There is no way they can sit a question like this and give you, based on what it is that I had projected, and give you less than 20 marks. If they ask for something else, sure. But this, no. But I'm expecting a 30 marker. So what's the point, sir? You know, have to catch it. Don't leave tonight, class, without you understanding the topic. All right. Mason, you had something to say, Pops?
No, sir. That's my understand
Okay.
that differentiation
Okay.
part.
No, it's not the differentiation part. I know you understand the differentiation. Do you understand the factorization right down here? So you understand the factorization here?
Unfortunately, sir, I'm not answer the factorization part. That's part there the screen freeze for me. Yeah, scroll. Yep,
You still not
seeing
seeing
it
it?
now. Yep, seeing it
Okay,
now.
okay. All right, cool. Lekarna, you're seeing something also. What was it?
Wasn't seeing that part where it just show what I was saying.
Oh, okay, got you. No
But
problem.
I get up to the second row, sir. That's about.
Right here, sir?
Yes, sir.
Okay, that's the differentiation. All right. So that tells me then that I need to go through the other parts of the question. Not a
And I
problem.
understand where you get the 0 because I read it in the notes when I was reading the stationary part. But anything after that is blank.
No problem. So let's start from scratch again. Whenever you go into the exam, as I said before, I'm expecting a 30 marker on this. A 30 marker on this.
Yes, sir. Just one equal to.
Say it again, can I?
Yes, sir. Just saw one on a past paper earlier.
All right. All right.
30 marks.
Good job. Don't put that. If you could screenshot it and drop it in the chat, I'd appreciate it, please.
Okay, sir.
Good, thanks, Pops. Now, once you see the question, it means that they're asking you to differentiate the function. They're asking you to differentiate the function. They're given y equal a cubic equation. I started off using an example with a quadratic. Don't expect to get a quadratic in the exam. And if you do get a quadratic in the exam, it may be no more than 10 marks. Because that's so much easier than doing the cubic equation. But when I differentiate the cubic, I'll reduce it to a quadratic. So when I differentiate this function, I'm going to get 3x squared minus 6x minus 24. 3x squared minus 6x minus 24. Now recall, for a stationary point, you put the derivative equals 0, or you put dy by dx equals 0, same difference. Set the expression equals to 0. That is how we're going to be finding the stationary point.
All right,
Then,
sir. My question is, you see, why you know, put the factors in a bracket with the 3 outside for the factorization part?
Right here, I'm not factorizing. I'm looking at the question here. Let 3x squared minus 6x minus 24 equals 0, the differential. And I'm seeing that 3 is common to all 3 terms. 3 is common to all 3 terms. 3x squared minus 6x minus 24. So therefore, in order to reduce the equation, to make life so much easier for me to factorize, what am I saying to you, Alwyn, is that I have to go multiply 3 by 24 to get 72. And then find factors of 72 when multiplied together give 72, but when added give me a negative 6. That's a too big number, too big a number. So when I look at it and I say, you know what, 3 is common to all the terms, and therefore I'm going to divide through by 3. I will reduce my equation to x squared minus 2x minus 8. Follow what I'm saying?
Yes, sir.
All right, look how easy this is now. The coefficient of x squared is now 1. When I multiply 1 by 8, by negative 8, I'm going to get negative 8. I need 2 numbers. When multiplied together gives negative 8, but when added gives a negative 2. The only 2 numbers could be negative 4 and positive 2. So now I'm going to be grouping. I'm breaking up my negative 2 into negative 4x and positive 2x.
Oh.
So that's what I did right here.
Okay.
So grouping, put the first 2 in one parenthesis. See it here? Leave out the middle sign every time. The last 2, we'll put in the parenthesis.
Okay.
And I say, what is common between x squared and negative 4x? What is common? X. Can you see that?
Yes, sir.
What is left when I take out an x from x squared?
X.
See it right here, so? What is left when I take out an x from negative 4x?
Negative 4.
Good job. So that's what I did.
Yes, sir. Get seen it now. Get it, man.
All right. And what is common between 2x and negative 8?
2. Hear me? 2.
Good job. And then when I take 2 from 2x, what do I have left?
X.
See it right here? And when I take 2 from 8, what do I have left?
Negative 4.
Very good. Now remember, whatsoever is in this parentheses must be the same thing in this parentheses. Must.
Yes,
So
sir.
therefore, x minus 4 is common to both terms. True or false?
True, sir.
So that's why I took out the x minus 4. And when I take out x minus 4 from this, what do I have left? See here, x. You see that?
Yes, sir.
And when I take out the x minus 4 from here, what do I have left?
2.
Positive 2. And that's why it goes in this parenthesis, positive 2. So now, either this x minus 4 equals 0, or this x plus 2 equals 0. See there? And if x plus 2 is equal to 0, I need to find a value. When added to 2 will give me 0. All we're doing is just looking at the opposites. What is the opposite of positive 2?
Negative 2.
Negative 2. So your answer here is going to be negative 2. What is the opposite of negative 4?
Positive 4.
See there? Answer is positive 4. Pressing pause. Everybody seeing what is happening here now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Good
sir.
job.
So I'm sure what they do one topic similar to that already.
Oh, yeah. When I was doing piecewise function.
Yeah.
Piecewise function.
But I did say to you, though, you know. I did say to you when I was doing piecewise that this is going to come back to you sometime later. Anybody remember that?
Yes, sir.
Yes, sir.
Yeah, man.
Yes,
Yeah, man. I did say, learn this now, because sometime later it is going to come back to haunt you. Here it is. Okay. So now these are called my stationary values. My stationary values. X equals 2. Logan, are you here? No, they are not. Logan. Logan is not here. A-R-I-S. Oh, Christian is here. So, Chris, you don't answer me.
I didn't hear you calling, sir. I'm here.
Anyway, cool. All right. So those are known as my stationary values. Stationary values. In order for me to get the stationary points, I must substitute this x equals negative 2 into the original function. Every time we're substituting, guys, remember, every time we're substituting, we are substituting into the original function. Make a note of that somewhere, write it on your forehead, stamp it in your head. Every time we're making a substitution, we are substituted into the original function. So, do for me, because this is your work tonight and not mine, do for me that substitution. Do for me that substitution of x equals negative 2 into the original function. And also, I want to do the substitution when x equals positive 4. Quick and fast. I'm right here, so if you have a problem, just let me know. I don't want you to just sit in class and suffer. It's not a good feeling.
Sir, I got 28 and negative 80.
That's so like return. What you say a while ago, Pops?
28 and negative 80, sir.
Nobody see the return. That response is, I am in half a tree. I come from country, and I say to you, how do I get to Excelsior? And you say to me, take a bus.
Oh, y equal to is that a better
No.
no.
What is corresponding to 28?
Oh, you wanted the x and y values, sir.
Yeah, but you can't tell me 28 and negative 8. It don't mean nothing to me now. You have to tell me that y is equals to 28 when x equals negative 2. And then y is equals to negative 8. Yeah, man. And I'm very particular with that because it is those two combinations now that will give us our stationary points. See it here? So in order to determine the stationary points, we must now substitute the stationary values into the original function. You cannot forget that it is going to be the original function. Anywhere in that function you see x, you're going to substitute -2. You work it, and you're going to get y equals 28. So therefore, the stationary point, when x equals -2, y equals 28. So it's going to be -2, 28. Similarly, when x equal to 4, anywhere in the function you see x, the original function that is, you see x, and you put 4 there, you're going to work on twerk, you're going to end up at -80. I'm pressing pause because you have to actually put pen to paper in order to get this thing. So I'm giving you an opportunity. Very good, Raycon. I'm giving you an opportunity, the rest of you, to do that quick substitution to confirm your y equals 28 when x equals -2 and your y equals -80 when x is equals to +4.
Yes, sir. I try to get it, sir.
Good job. All right. So we have found our stationary points. So the first part of question for 6 marks.
Sir, I'm not done.
Okay, 2 seconds. Finish now?
Yes, sir. Come on.
Cool. All right. Now that you've completed the stationary point, it is now asking us to calculate the coordinates of the y-intercept. Which one of them will make equal 0?
X.
Very good. Excellent. See? When you can't feel the course. Can't feel the course. So when I go over to the teacher for calculus 2, can't feel the course. Proud of you. So whenever they ask to find the y-intercept, x is going to be equal to 0. If they ask you to find the x-intercept, you're going to put y equal. Always remember, it is the opposite one that you're putting equals to 0. Let's go. Anywhere in this function, I see x. I'm going to put 0. So this is 0. This is 0. Uh-oh. Oh, dear.
0,
What's the
sir.
answer?
Easy. 0.
0, sir.
Wrong.
0.
Wrong.
0.
What's the coordinates of the y-intercept?
0 and 0.
Thank you. 0, 0. Kenneth, don't say nothing to me. I don't want to
Sir.
hear it, Kenneth. I don't want to hear
Sir, you don't say nothing to do.
it. Kenneth, you said 0, Kenneth.
0 and 0. Yes, sir.
Good. Thank you, sir. Yeah, man. Say 0, 0. So what I want you to see, I can't just put y equals 0. Why? Because it says the coordinate. So to write a coordinate, it must be in the form x, y. Guys, remember that because you will lose the 1 mark. I do not want. Let me just pause and just say something to you. Some years ago, I was teaching this course, and the student understood this topic, answered the question pretty well for this topic, and answered a second question. But from the start of the question, the student made a mistake, and it took the student right through the question. So the student got full marks for this. So the student got full 30 out of 60 for section B. And the student can't tell you what the student got for the section A. But when I press equal, the student passed the course. So what am I saying to you is, I am telling you the things that I'm looking for so that you don't make the mistake that you can't afford to give up a mark or 2. I don't want that to happen. So everything that I'm saying as it regards to this topic, jot it down somewhere in your notebook to remember. When it says coordinate of the y-intercept, you can't just put y equals 0, sir. No, watch this. Coordinate of the y-intercept is 0, 0. All right. So now, we're supposed to be classifying them. Sure. How far up?
No, man, go back down to the coordinate of y-intercept. I just want to make sure I have this recorded. Okay, thanks.
Hold on, now. Is you know waiting until Papa, you finish here?
Yes, sir, you can go down. Thank you.
Okay. So now, it says that I'm supposed to classify the stationary points. Now, having found the stationary points, it wants me now to classify the stationary points. Now, guess what? There are 2 ways of doing this. Time is against me. If I have enough time, I will do the other method. The reason I'm doing this method is that students normally gravitate towards this method. And this method will also help you for the other questions to come. Because for this method, you have to calculate the second derivative. You have to calculate the second derivative. Means that you're going to do the differentiation one more time. And the other question that normally comes in terms of the point of inflection, you are going to need a second derivative. So it's just as cheap. You calculate it from up top, and then you just record it on the bottom. Let's go. If dy by dx is equal to 3x squared minus 6x minus 24, when I differentiate that one more time, what do I get? Yeah, 6x minus 6 on the
6x
screen.
minus 6. Yep.
It's on the screen, 6x minus 6. Everybody, so I get 6x minus 6?
Yes, sir.
6x minus 6. Guess what? That 2 must be set equals to, well, this is when it's set equals to 0 for the other part of the question. You're only going to find the second derivative, and then you're going to substitute your stationary point. Now remember, my stationary point was negative 2, 28. Anywhere in the second derivative, I see x or y because I have two coordinates here. The x is the first one, the y is the second one. Now, if you want to remember which one of them come first in the parentheses, when you say A, B, C, which is the second to last letter in the alphabet?
Sir, why?
Y, sir.
Which is the third letter, third to last.
X.
So which one come first? Y or X?
X.
Very good. So X come first, it the in front. All right? Y come last, it the run so. So if you want to remember at all times which one of these variables is written first in the coordinate form, the X is always written before the Y. So you're going to be looking at your stationary point -2,28. Anywhere in the second derivative, you see any of the two variables. Now, in the single variable function, you'll only see X. In the single variable function, which is what we're doing for calculus 1, you will only see X. You're not going to see anything in Y. When you move to calculus 2, you are going to see that when you reach this point, you're going to have both X and Y into the second derivative, because you're going to be doing something that is called multivariable functions. Multivariable functions. All right, watch me. Anywhere in the second derivative, I see X, I'm going to substitute this -2. 6 times -2, see it right here, so? It's a -12. And -12 minus 6 is a negative number. Talk truth.
Yes, sir.
Repeat, sir.
Anywhere in the function, I see X. Anywhere in the second derivative, that is, I see X, I'm going to substitute -2. So 6 times -2 is -12. -12 minus 6 is -18. It's a negative number, don't?
Yes, sir.
And once you have a negative number, once it's negative, it's a local maximum.
Maximum. As long as it's less than 0.
So
Yeah.
run back the line there again, please, and thanks.
No problem. You understand the second derivative story?
Yes, sir.
Good. So when you have found the second derivative, you are going to substitute your stationary points into the second derivative. For single variable functions, you won't see Y in it because you would have differentiated out the Y's. For multivariable function, you will end up seeing a Y, so you can substitute both X and Y. That is for next semester. So I can safely say for this semester, you will only substitute your X's in the function. So anywhere in the second derivative, I see X, I'm substituting -2. So 6X minus 6, here goes the X, so you're going to substitute -2. See it right here? 6 times -2 is -12. 6 times -2 is -12, and -12 minus 6 is -18. I'm only interested in it being a negative number. Once it is negative, it suggests that you have a local minimum. Similarly, in the same second derivative.
One on the sir.
Go
That
ahead.
way you say contradict what you have in the red. You say once it's negative, that suggests that it's a local maximum.
Right. I said minimum.
Yes, sir, you did.
Is to see if you're paying attention, and you're the only one that's paying attention.
Sir.
Kenneth, don't say nothing, Kenneth. Kenneth, don't say nothing. Yeah, man. So negative is maximum. Negative is maximum. Aye.
But sir, logically looking at it, that sounds confusing.
You hear me pause a while ago? I paused a while ago because when you move on to calculus 2, that statement that I just made, I will have to do something. I'd have to do something. I'd have to go fix it up. I have to put on some clothes on it. It have on clothes enough, but I have to put on a jacket now or a vest because something I have to go change up. Let me show you why. Let me show you. Maybe this will help you for this level. At this stage,
Sir,
a local.
Yeah, me I beg you not go too far. You hear come
You
me
don't
bear
go
me
too
barely
far and I
catch on
can't
on it.
too. No matter go too far and I can't say.
Yeah, but me don't want to lose this. Me barely a catch on. So me just
No,
allow-
hold up. I don't know about your teaching strategy, but my teaching strategy says, I have to tell you, because when you get to that stage, I'm preparing you from now for calculus 2. So when you get to that stage, I don't want none of it to say, but sir, you just said this in calculus 1, because I would have already told you for calculus 2. So let me show you something. No. I mean, I don't care what you want to say. This is a local maximum. When the graph turns down, it's a local maximum. What shape of the alphabet is this?
Sir,
N.
N, E, G, A, T, I, V, E.
Negative.
You get the gist of it? You see it right there, sir?
Yes, sir.
Interesting.
So anywhere, I'm here to teach it, you know. Anywhere you see you have a negative, the graph will go turn this way down. And when it turns this way, it looks like an N for negative. You will use this concept in calculus 1. You will use this concept in calculus 2. Hatch it somewhere in your headspace because you must know it. Does that make sense?
yes, sir.
Yes, sir.
All right.
So, sir, we have to write case 1 and case 2 when you do the exam.
Same way. Same as a papa. Let me show you, because remember says 2 stationary points we have enough. In this case, any amount of stationary points, that's the number of cases we look at. No, it's when you're not studying. Study in pairs, not person, but in opposites. So if we talk about a local maximum, what is going to happen is the local minimum is going to be the reverse of it. So the local, if this turns down, wait till the minimum can turn.
You.
Up, sir.
Very good. Don't ask me always positive. But if this one spell N, E, G, A, T, I, V, E, that means the opposite one got to be this one.
UP.
So this is going to be the minimum, and the minimum is going to be positive. Follow me?
Gotcha, sir. Gotcha.
All right. Please to remember this. You cannot forget this. You cannot forget it. I'm going to pause right here. And I'm going to ask you, are there any questions?
Yes, sir.
Go ahead, Papa.
Explain us the line that was said, therefore, D, what that?
D squared Y by D squared.
Yeah, explain what that I said right there, sir.
So this here is the first differential, dy by dx. The first differential. This one here is going to be the second differential.
We're required to know any more than 2 in a calculus 1?
Yes, I think you go up to the third differential.
So that would be D cube Y over dx cube.
If a 3, if I the third, where it's supposed to be.
Come on, I didn't ask you a while ago if it would be
B
D
what?
cube.
Oh, it's cube, is it? Okay,
Yeah,
sorry.
D
D
cube
cube
Y
by.
over dx cube.
Very good, Pops.
Okay.
But you'll not find a third derivative in this question. I'll show you a little later on. You see, what I didn't do with you for the differentiation was the second and the third differential. Why? Because I needed to get to this topic. It's when I know and understand this topic, I can go back to differentiation and I can do more second derivatives and third derivatives with you. I needed to just get to this topic, so I just gave you the basics of it. All right, so let me just go through this, what we did a while ago here. Yes, I agree with you, Nigel, that this thing kind of look, contrary to what it is that we know. Because if it says a maximum, why is it negative? If I confess to you, that was one of the challenges that I had when I was doing CXC maths, when this was presented to me. And then you won't see anybody have this like this. with the negative business. Me invent this. This is what I had to use as a student to convince myself that when it is negative, I'm spelling the word negative and it turns down. That means my graph, my negative graph also turns this way. I still cannot find an explanation for this. So, you know, I said to myself, this is the opposite of this one. And if it is not a maximum, it got to be a minimum. All right. So remember now, when it is positive, the graph is going to turn upwards like a U. When it is negative, it spells the word negative, beginning with N. Do you also recognize that it's the same d squared y by dx squared that we are using? So I'm just recalling all of this. So once I recall dy by dx, I differentiate it one more time to get d squared y by dx squared. Any questions? Or any other questions?
Sorry. We get the 6x minus 6.
I differentiated this to my dy by dx. One more time to give me d squared y by dx squared.
That make it so keen, sir.
That's why I'm not moving. You notice me now talk? Wait, I don't know if you tell me so I can go.
Guys, when me did do the first part, I should have that 6x minus 6 very obvious. So when you do it in the first part, but when we see you show your solution, you know, so I'm not go so far yet.
Not yet.
Why? Like I know, but now I gotta lie, the same exact thing me do.
Never mind. And we're learning, so that's fine. I won't kill you too much.
You stop right at the 3x squared minus 6x minus 20 equals 0.
Right.
Realize you not go so far after.
The same thing me do, sir, unfortunately.
Yeah. And that's fine. You're learning. So by the time I give you the next question shortly thereafter, I'm sure you're not going to make that mistake again. Very good. Are there any other questions? Any other confessions?
So if it's just a confession, even though I was the first one in the class, I ended up having to leave. I came back 5 minutes ago, so missed quite a bit. So I'll have to catch up on the recording.
That's going to cost you.
It will, but I had to.
Absolutely. Well, not academically, but otherwise, but never mind. You'll catch up. I'm going to go through other questions.
Yes, sir.
All right. So let's just go back now. Stationary point. We calculate the coordinate of the y-axis. We classify the stationary point. Now, watch me. To do the stationary point, we have to differentiate the function. Yo. Go ahead, Papa. All right. So to calculate the stationary point, by the way, you guys are hearing me?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay. So to calculate the stationary point, I'm going to differentiate the function, set it equal to 0, work it and twerk it, solve it, get my stationary values. When I get my stationary value or values, I'm going to substitute it into the original function to obtain the corresponding y coordinates or y values. And when I put them together, I'm going to get the stationary points or turning points or critical points. They all mean the same thing. To calculate the coordinate of the y-intercept, I'm going to put x equals 0. Not y, because it's the opposite one that you're putting equals to 0.
So it's a turning point, critical point and stationary point mean the same thing, right?
Yes, Papa.
All right.
To classify the stationary points, I'm going to find the second derivative. So I'm going to look back at the first derivative. And I'm going to differentiate it one more time to get the second derivative. When I get the second derivative, I'm going to put it down. And then I'm going to go for my stationary point or my stationary points and substitute the value of the variable, corresponding variable. If there's an x in it, I substitute the value of x. If there's a y in it, I substitute the value of y. And I'm saying that the y part is going to come for calculus 2. So for now, you can rest assured that we're only going to be seeing x's for cal 1. Don't be surprised when I move to cal 2, and I'm going to tell you otherwise. If nobody asks me that question, I'm not going to respond to you because you're supposed to remember.
So I'll make sure it's you teaching it, please.
All right, let's go. This. So when we do the stationary points, when we're classifying the stationary points now, what we're going to be doing is, if the value comes out to be negative, negative is spelled N, it turns downwards. Once it turns downwards, the maximum. I will show you why I call it a maximum. And the opposite is just the minimum. All right. So I did a recap of 1, 2, 3. Now I'm going to go to the point of inflection. Matter of fact, I'm going to stay right here, because the point of inflection is me calculating the second derivative of the function. But I would have calculated the second derivative from up here, so in part 3. I'd have calculated the second derivative from part 3. Andrew, you not seen the screen?
Data low, sir.
Huh?
Data low.
Sir, sir, yeah. Sir, every minute we get kicked off, you know. Something wrong with flow right now. All my internet at home now. But the data on my phone, trust me, kick me off every second.
Yeah, man, it's a known thing, Andrew.
Work, you know.
It's a known thing with Flow. From there, them actually send out a broadcast about it.
So it depends by area, because I'm not gonna problem.
There was an issue, there was a big accident me here, man. So it affect Kingston and St. Catherine.
Wow.
Parts of.
St. Catherine, mean?
Well,
Parts of.
So that explains it now.
Yeah, man, me get affected too, man.
All right.
Send a screenshot.
Okay, no, he's still here. Sorry, somebody was saying something? Screenshots?
No,
oh, yeah, yeah.
Group,
okay, thank you, Papa. Wow, nice class. All right. Now, so I was saying to you, I'm going to say right here before I go back to that one. To determine the point of inflection, you're going to need a second derivative. To determine the point of inflection, you're going to need a second derivative. You're going to need a second derivative. But you would have already calculated the second derivative from up here. Say it again.
The 6x something, sir?
Yes. But this time now, for the point of inflection, you can set it equals to 0.
So 6x minus 6 equals 0?
Yes, Papa. So you're going to set that equals to 0.
And then you carry something.
And then you solve for the value of x. So 6x minus x equals 0. 6x minus 6 equals 0. Then you're going to add 6 to both sides. So you get 6x equals 6. And then you divide both sides by 6. You can get x equals 1. Can you all see that?
Yes, sir.
Yes, sir.
Good job. Which equation are you going to substitute it into again? The original.
Second, original.
The original. You always do your substitution in the original. So you can go to the original function, y equals x cubed minus 3x. So keep your question nearby. Because like all this now, you just grab for the question paper. When you grab for the question paper and the question paper say that, you just write it out from here, so. And don't trust necessarily what you wrote in a book. Just write everything from the question paper. There's something that I need to tell you now, because I don't want you guys fall prey of it. So I need to tell you. All right. So the point of inflection, you are going to substitute it into the original. You write the original from the question paper, and you put it in anywhere in the function you see x, you're going to put 1. So it's 1 cubed minus 3 times 1 square minus 24 times 1. 1 cubed is 1. 1 squared is also 1, but 1 times negative 3 is negative 3. And negative 24 times 1 is negative 24. And 1 minus 3 is negative 2. And negative 2 minus 24 is negative 26. So my point of inflection is going to be 1 comma negative 26. I can't report it as just negative 26 because it is the coordinate of the sub. When you're putting something on a graph, I can't just put 26. You know, I was teaching a class yesterday, Monday. I was teaching a class on Monday. And I was saying to the students that that's why I like driving in the States. Because those places are made in blocks. So if I'm going to Excelsior Community College, I will say it is on Deanery Road and Mountain View Avenue. So I'm giving you a landmark. Once you get to Deanery and Mountain View, you must find Excelsior Community College because once you get there, you look over, you're going to say, Selby. So you know that you're in a general area. So if I tell you, say, Excelsior is up on Mountain View. Mountain View is a long road. Where do I come off? And this is what the coordinate is saying to you. My X and my Y values are working synchronously. When I start sketching the graph, you're going to see how important that is. Oh, so let me pause right here and say 2 things to you.
So otherwise, you can say they are directions.
Yes, there are directions. That's why I gave you that example. There are directions. Let me tell you 2 things that I'm cautioning you on. Do you recognize that? Do you recognize that if your differentiation wrong right here, so when you set it equals to 0, the rest of this will go wrong? Anybody say? Huh?
Yes, sir.
Yeah.
Yes, sir, because that's where the second derivative come from.
Right. And if that wrong, you recognize that you may get this right, but that not depend on nothing. But you recognize say this will go wrong, and you recognize say this piece will go wrong too. Yeah. So I'm saying to you, if you plan to do this question, be patient. Take your time. Do your differentiation. Pivot and recheck your differentiation. And every time you do another part of the question, recheck your differentiation. We cannot afford to give up any marks. And the other thing to it is, normally you get about 3 marks or so for sketching the graph. Some students lose those 3 marks because they don't have the patience to sketch the graph and make the graph look like it makes sense. And it don't make sense, you can get 30 out of 30 and go in there and get 27 out of 30. Them 3 marks can cause you to fail the course. All right? So let's continue. The last part of the question now is the sketch. Okay. So the last part of the question is the sketch. I want all eyes on deck. Don't blink. Look at what I'm doing. You know, we're going to the exam and get the graph paper. Because it is a
So that means we have to carry one graph paper or just sketch it freehanded.
Yeah, that's what this means. Sketch is going to be freehand. You're not plotting. You're not plotting anything. Don't go in and ask on a graph paper because the man them not going to give you.
Sir, by any chance, do you get a mark for that?
Get mark for what?
To sketch it.
Well, Kenneth will tell you because he found one on the, not Kenneth, Mason will tell you because he found a past paper. So we're going to look at the past paper after this.
Negative, not me, sir.
Uh-oh.
Kenneth.
Kenneth,
Kenneth.
no, you call the right name first.
Kenneth, yeah, Kenneth. Yeah. So when we look at the question that Kenneth presented, we're going to see if them give any marks for it. Watch me. And I'm going to show you this, you know, because if I show you this, I'm going to say, sir, oh, me not understand it. This was a plot. And I plotted it because, you know, I wanted to come to class and show you something. So I just plotted so it can look neat. So this is an exact plot. Huh?
Yeah, I think me understand it.
You think you understand it?
Yes, sir.
Good job, my papa. Good job. Good job. All right, let's go. Let's go. Which axis go so again? Over here, so. What this one over here, name? Which axis?
Why?
Which one, sir?
The horizontal axis is there?
X-axis.
Is my x-axis, and my vertical axis therefore is going to be my y-axis.
Rise over run.
Rise over run. Yeah, that's in the calculating gradient. All right, let's go. This part is a nice part, and I want you to pay attention. Every single point that you've calculated on this something here, weighing up on it. You see, we calculate a point 0, 0, which is a y-intercept. We're going to plot 0, 0. Where's 0, 0 on this Cartesian plane?
Let me go.
Right there, so 0, and look at how I do it. I put an X and then I highlight it. Nobody put a dot, because when you put a dot and you draw the line, I'm not going to see where the dot is. So I put an X and highlight it. So I put my first point there. I'm not going to put on the point of inflection in there because I don't want to confuse myself. Then I'm going to put on my stationary point. -2, 28. -2, 28. So if this is over here, says positive, I call this +1, +2. That means negative is going to be over this side. Talk truth.
True.
And 28, I'm going to call 28 right up here. So 28. Then, sir, you can do it. So is my sketch. It is my sketch. So, as I was saying to you, why I like foreign is that the people them talk in blocks. Can you see this block right here? So the intersection of those two blocks would be my coordinate. And that -2, 28 is going to be my local maximum. And my local maximum is a graph that turns down. Talk truth.
Yes, sir.
So therefore, I saw the graph I go look. A graph to me say turn down. So I saw it I go look turning that way. But I don't finish yet. I have a 4, -80. I have a 4, -80. So that is 2. Call that 3, call that 4. And I'm going to call my negative. Oh, my -80 is up top here, so don't.
Bottom.
Okay. I'm gonna call my -80 somewhere down here. So -80. So -4, +4, -80. I read off of my graph. The intersection there gives me a coordinate. Is that a maximum or a minimum?
Minimum.
A minimum turn where? Up or down?
Up.
So this a graph that comes somewhere up here. So
we can't get
that long, you know. Because me know how my graph them turn. But guess what now? Something kind of look like it won't for something else. Let me just check. Oh no, sir, but you have it already. You have the -228, you have the 4, -80, you have the 0, 0. Here's one more point. Oh, the point of inflection. I'm not gonna put on the point of inflection yet. Look at what I'm gonna do. Hey, trouble. I'm gonna erase this. I used my big toe to draw that a while ago. And then I'm going to go back and then I'm going to do this.
Okay.
And that is going to be my sketch of my graph. Then, sir, where's the 1? Where's the 1, negative 26? Right here, so. Everybody see that? The point of inflection is the midpoint between the maximum and the minimum value. Is the midpoint between the maximum and the minimum value.
So after we draw sketchy the local minimum and maximum, I will just put the coordinates for the line for the point of inflection.
Yeah. Yeah. So watch this now. But sir, that graph don't look like this graph. It does. But it's just that this graph now, my negative 80 is on here. So you can see this. This is my negative 80. And how this graph look now, this is like 5, 10, 15, 20. So this is a 5. So 5 will be right here. So coming over a little bit more will be 4. So this is going to be my positive 4, negative 80. See here, positive 4, negative 80. So this is 4, negative 80. This is 1, negative 26. That's 0, 0. And this is 2, negative 2, 28. Is that difficult?
No, sir.
I don't think so. All right. So if you look at it here, my negative 2, 28 would be negative 2, 28 right up here. So, and of course, it's my negative 4, 80. Sorry, positive 4, negative 80. And my 0, 0 is right here. So, guys, it's not bad. It really isn't bad. And I really hope that you gravitate towards it. But I will know. Boy, it's a Kenneth to see you. You know,
that's the point of inflection, sir.
That's the point of inflection. Yes, Papa. See you, Kenneth. Copy.
Sir?
Yeah.
Sir, I'm not going to lie. I looked away for like 2 seconds, and look back
and the graph plot.
Yes, sir.
I see my set, Papa. See my set, bro.
So where's about the point of inflection now again?
It's a midpoint between the maximum and minimum. The midpoint between the maximum and minimum.
So, but you haven't plotted it here.
For what? I did. Did I not?
Right on the graph, sir.
You haven't, you haven't written it on the graph. That's what I mean, right here.
Okay.
Now it's sketchy now, but this.
No. I get what you say.
Okay.
I get what you say. You're saying that I didn't write it here, so it was negative 20, negative 25, right here, so negative 25, negative 26, right here, so that's my POI, point of inflection. All right, guys. We're moving nicely. We have less than half an hour left, and there's a question here now. Whoever asked a question earlier, I can't remember, can't recall. But look at this now. It says, given the function Rockstone, does this look any different from the question that I gave you up here? So 1, 2, 3, 4, 5 something, and this end up having how much parts? 1, 2, 3, 4, 5. It's the same thing. 30 marks. Somebody asks a question, sir, will we get any marks to plot the graph or to sketch the graph? How many marks were given to sketch the graph?
8.
All right. All of 8 marks. So if you catch everything right in part A and decide say now that the part B at 22 out of 30, you will get 73%, 74%, as opposed to getting 100%. So we need to learn to sketch the graph. All right, what I'm going to do, we need to finish this question I'm giving you 15 minutes to do the question, and then I'll come and put the icing on the cake. Pick and pass. 15 minutes to do this question for me. Yeah.
Sorry, you can scroll back to the first graph, the one that you sketched. It's for a second. Yeah, I got it, sir. Thanks.
You all know me get the point of inflection. I'm chip out about 1 million times.
Don't worry about it, man. When you get a chance, link me and then I can explain to you. I understand the struggles. Obviously, have you completed the stationary points? Yes.
Boy, sir, man, try to work out the factors, sir.
Almost.
No problem. Take your time, the plan, and see if you can go through. Just take your time. You'll be fine. Just take your time.
They said the factors have to be can multiply to get the constant.
Not you can, you have to. You have to multiply the coefficient of x squared by the constant.
Sir.
Yeah.
Is it possible to get a half as one of the stationary points?
To get a half?
Yeah.
It is possible, but I don't know if the half is the answer for this one, but it is possible. Yeah, man, it can stop it and get yeah, man, it can get it, man. Yeah, man, very possible. And you can get 1/3, and you can get liberties. Yeah, man. Don't always have to be a whole number. I think that's the question you're asking.
Yes, sir. So, so if you get a fraction, you can just convert it to decimal. Huh?
Nope. Fraction. How far we reach?
It is stationary points, sir. I got through back.
Are you okay with that?
Yes, sir. I get that.
Yes, sir.
Yes, sir.
So therefore, For stationary point, f dash of x is equal to 0. Therefore, I'm going to let 12x squared minus 30x plus 12 equals 0. What is common throughout that equation?
3, sir.
Really?
6.
6.
6. 6, yeah, 6. Yes, let me go.
So since my 6 is common, I'm going to divide through.
So, you know, I did it twice. I used 3 first, divided through by 3, and then I realized that I could still
divide it again by 3.
Divide it again by 2, actually.
By 2. Yeah. 2 times 3 is 6.
Sir.
Come on.
So I did that twice, but I came back to the same place.
Good job. So it should come back to 2x squared
minus 5
minus
2.
5x plus 2. Good job.
Equals 0. Right.
And that's what I'm going to factorize now. So I'm going to multiply this 2 in front of the x squared by the constant 2 to get 4. I need 2 numbers. When multiplied together will give me 4, but when added will give me a negative 5. What numbers do you think of?
1 and 4.
What kind?
Negative.
Negative.
Negative 1. Negative 1, negative 4.
So factors are negative 1 and negative 4. So watch me. 2x squared minus x minus 4x plus 2 equals 0.
Good.
On that group, I'm going to have 2x squared minus x in one bracket. I leave my middle sign out every single time. And because it's a negative sign outside here, that sign from a plus is going to shift to a negative. Why, sir? Thank you for asking. When I multiply this negative 1 by this positive 4, I get a negative 4. When I multiply this negative 1 by a negative 2, I'm going to get a positive 2. Whatever sign that is here has to be the same sign that is here. What is common here? That is common here.
X.
What is left?
2x minus 1.
What is common here? That is common there.
2.
And what is left?
2x minus 1. Plus.
2x minus 1. What is common here? That is common there.
2x minus 1.
What is left?
X minus 2.
You notice every time I wrote my I put my equals 0 equals 0.
Yes, sir.
It is an equation, so I have to keep it. I have to maintain that. I have to maintain that. Equals 0 equals 0. All right. So either.
Well, honestly, sir, not right back f of x equal every time, like every point. Oh, good.
So what I'm going to do now is to say either two x minus 1 equals 0, which implies x is equal to a half. That's why Alvin asked a question. Or x minus 2 equals 0, which implies x is equal to positive 2. All agreed?
I agree, sir.
I'm going to put x equals a half into what?
Sir. So it's back into the original function.
Good. So we can look at case 1. Let x equals negative 2. No, x equals a half first. I don't have. I could do that one, but I just want to do the half one first. Let x equals a half. So therefore, I'm going to have f of a half is equals to 4 times a half cube minus 15 times a half square plus 12 times a half minus 8. 4 times a half cubed is 1 to the third power is 1, and 2 to the third power is 8. So that's 1/8. Minus 15, 1 to the second power is 1, 2 to the second power is 4. So that's a quarter. Plus 12 times 1/2 minus 8. 4 times 1/8 is going to be 4/8. Let me just do it. I don't want it to. That's going to be minus 15/4 plus 12/2 minus 8. Four over 8 is a half. What did I do it? Yeah, let me just do it like that. 4/8 is a half. Minus 16/4 is 3 3/4. 12/2 is 6 minus 8. And this is going to be, I'm doing all of this in my head, incidentally. A half minus 3/4 is going to leave a quarter. So this is negative 3¼ 6 minus 8 minus 2. So negative 5¼ Anybody got that?
Here is so far, sir.
Okay. All right. So this is going to, so stationary point is going to be a half, comma, negative 5¼ All right, we're going to stop here. So that you can go to your other class and I can go to my other class. We will continue. Matter of fact, I'm expecting that you guys will continue with this document, this question, sorry, and find more questions in the past paper, drop it into your WhatsApp group and challenge your classmates to do the answer. Challenge your classmates. Guys.
So this question shall equal 50 marks.
It is a must-have. I congratulate you, Alway, because you seem as if you're following and you weren't here for quite a while. So it suggests that you were in absence here. You were doing your own revision. Proud of you, Papa. All right, guys.
Sir, respect, you know?
He's a Papa. I want you all to study. I'm missing Logan and I'm missing Miss B, Miss KB. She never talked to me in class today. I don't know if she reached out
Still here. So I think you know my dilemma. I am lost,
okay.
so lost. I'm gone through the roof of lostness. I just don't have the time to look over. I'm just overwhelmed and lost. I'm just lost. At this point, I'm putting down the money to do this course again.
Excuse me?
Yeah.
How much you say
I make sure I put down 100,000. I went to my account. I put down 100,000. Push come to shove, I'll do it over again because I'm lost. And I make sure I'm doing it over alone. Like I won't have any other course except for this one.
Sir, Chris, I deserve a beating. All right, sir. So I will support you.
No, and
I support you,
guess
sir.
what? And guess what? When them call stick from country, Kaya. Yeah. Kuchu Maka stick. And that you must use for now. All right, guys. Remember we had planned for a little session tomorrow. Are we still on?
Yes, sir.
Live, sir. What time was it? Midday?
I was saying midday, right? Miss B, you need to make sure that you're there.
I will be there.
All right, cool.
So at 12 o'clock tomorrow during my lunch. I'll take lunch early.
Sir.
Right. So 12. Yes, please.
Sir, are you going to be in a specific class? Because I'm going to be at school tomorrow.
Okay, great. So you can come sit down with me then when I'm doing this stuff. I can, if I can't, if it's just you alone, I'll just be in office. But we don't have no whiteboard here. You have a stand playing?
No, sir, I don't.
Sir, I will be at school too.
Who's going to be at school
I
too?
will be at sir. Damoy, sir.
Okay, all right. You have a stand, Damoy? You can set up a phone so they can see what is happening in the class.
What, sir?
You know, one of those tripod stand.
Oh no, sir.
All righty. I'll find a classroom, and then we'll just go together there and get it done up. All right. So I look forward to seeing you guys tomorrow. Then I'm going to set up the link for 12 o'clock, and then I'll see those two students face to face.
Yes, sir.
Okay,
Leave up with the step. Later.
All right.
Yes, sir.
All right, sir.
All right, sir.
Nice.
Have a good one, guys.
All right, sir. Big up yourself.
You too, Papa.